Yes, sir, you're audible.
Okay. So this is Dr. Arunava. I'm the now an assistant professor of applied mathematics. Now I will teach you the GET mathematics, that is for aerospace and mechanical. Okay, and all the other streams. The GET mathematics syllabus are almost similar to all the streams except the computer science. Okay, and this field. So today we will learn the first chapter of this GET mathematics syllabus, which is the linear algebra, and which covers the matrix, its operations, determinant, inverse of a matrix, finding of eigenvalue and eigenvector, okay, finding the rank of a matrix, and all the others elementary operations on matrices. Okay, so I am sharing my screen. Please let me know whether my screen is seen to you. Is my screen visible to everyone?
Yes, sir. It's visible.
Okay, now I'm sharing the PPT of matrices. Is it visible? Everyone can see the PPT?
Yes, sir.
Okay. First, let me know that I will ask you a question, that is, are you familiar with matrices? That is, what is a matrix? Just the basic matrix. That is, it has a rows and columns, matrix multiplication or addition, just a simple operations on matrices, and just a very simple definition of matrix and simple operations. All ever about it?
Yes, sir.
Okay. You can write it in the chat box also. I can see the chat box. Okay. Okay, so I'm not going to define the matrix summation, as subtraction, and multiplication. Okay, directly I'm going to the higher versions, that is, which is only necessary for get questions, because I have very limited time. Okay, so first I will start with the very basic definition of matrix. So a rectangular array, you can see this is a matrix, a rectangular array. Array means which has some columns and some rows. So in general, we define the matrix as some rows and some columns, and the dimension we will define as m cross n, because there are m number of rows and n number of columns. Okay, so dimension is defined as m cross n, and the elements of the matrix is defined as, look at this, it is A11 because first row and first column. Okay, the first number is defines the row, and the second number defines the columns. If I write A32, it means this is third row and this is second column. Okay, so each and every element of the matrix is defined by this notation A11, A22, or A33, like this. And if you see the diagonal elements, each and every diagonal elements are represented by AII, and II means A11, A22, A33. Okay, so each and every diagonal element is represented by the same indices, that is 1, 1, 2, 2, 3, 3, and so on. Okay, so this is the basic representation of matrix. So as an example, simply 1, 2, 3, 4, if I write here. So this is a simple example of matrix, and which is 2 cross 2, means number of row is 2 and number of column is 2. And this 2 cross 2 is called the dimension of the matrix. Okay, just as look at this m cross n. Dimension of the matrix is m cross n, since m number of row and n number of column is there. So this is a very basic definition of matrices. Now, some of very important definitions which is applicable for GATE examination. Okay, you have to know these some properties, and you have to know some very basic definitions. First of all, square matrix. Square matrix is number of row and number of columns are equal. Okay, such that 1, 2, 3, 4. Look at this matrix. Okay, 1, 2, 3, 4. Number of row and number of column m and n is both equal to 2. So it is a square matrix. Secondly, identity matrix. And you know what is identity matrix? It is simply 1, 0, 0, 1. This is called 2 cross 2 identity matrix. If it is 3 cross 3, it is 1, 0, 0, 0, 1, 0, 0, 0, 1. It is 3 cross 3 identity matrix. Okay, and which is also defined as, if I multiply this identity matrix with any other matrix, then we can get the same matrix back. This is the example. Okay, look at this 1, 0, 0, 1 is multiplied by 1, 2, 3, 4. Okay, so then we can get back the same matrix 1, 2, 3, 4. So this is another definition of identity matrix. If you multiply this identity matrix with any other matrix, we will get back the same matrix again. Okay, it is just like the element, or just like the number 1. If I multiply this 1 with any other number, we can get back the same number. That is 1 into 2 equal to 2, like this. So in matrix 1, 0, 0, 1, or this identity matrix is the same, similar to 1. Next, diagonal matrix. Very simple definition. Except the diagonal elements, all the other elements are 0. So look at this. These are the diagonal elements 2, 3. Okay, diagonal elements may be anything. It may be 1, 1, 1, maybe 1, 2, 3, any number. There is any number. But all the other numbers except this diagonal will be 0. Then we will say this is a diagonal matrix. Okay, next one is upper triangular and lower triangular matrix. A very important definitions. Okay, because when you are going to find out the rank of a matrix, you have to convert the matrix as lower triangular. So upper triangular and lower triangular, these two matrices. Look at this. Upper triangular means if I divide this matrix like this, that is, these are the diagonal elements 1, 2, 3. Okay, the upside of the diagonal elements are all 0. Similarly, look at this. The upside of the diagonal elements are all 0. This is also upper triangular matrix. Don't bother about what are the diagonal element is, whether it is 0 or not. You don't bother about it. You just have to remember the upper portion of the diagonal elements will be 0. Then it is called upper triangular. Similarly, exactly the opposite one, lower triangular matrix. Just the below portion of these diagonal elements will be 0. Look at this. Lower triangular. Similarly, this is also another lower triangular matrix. Okay. So below portion, the downside portion of the diagonal elements all are 0. It means lower triangular. And the upper portion of the diagonal elements is 0. It is upper triangular matrices. Okay, remember these two definitions, because it will be very useful to find out the rank of a matrix. Next one, transpose of a matrix. I think you know this is familiar to you. If I interchange the rows and the columns, okay, it will become transpose of a matrix. So if A equal to 1, 2, 3, 4, so what is transpose? Just convert the rows and columns. So the first row is 1, 2. Okay, this 1, 2, you will convert it with first column. So in the first column, we will write 1, 2. Similarly, 3, 4, the second column, we will write 3, 4. It becomes the transpose. Now there are some properties of transpose. Transpose of a matrix. It becomes the same matrix. Okay, so you need to remember these properties. Very useful for GATE exam. Okay, many questions are there. If you don't remember this, you can't apply this instantly. Okay, so these are some properties. If the transpose, if two matrices are added to each other, the transpose will be there like this. Okay, A transpose and B transpose. Okay, C into A transpose, where C is a scalar. Scalar means just a single number, nothing else. Just 1, 2, 3, 4, or any other pointer like this. Okay, this property is very important. AB whole transpose equal to B transpose A transpose. Matrix multiplication is not commutative. Means A into B. A is a matrix, B is a matrix. This is not always equal to B into A. Okay, so if some cases if you write that A into B is equal to B into A, no, this is not always possible. Okay, commutative property doesn't hold in matrix. Okay, so in this case, AB whole transpose, it is always B transpose into A transpose. You cannot write it A transpose into B transpose. This is wrong. Okay, next. Symmetric and skew symmetric. Symmetric matrix is A transpose is equal to A. Okay, the transpose, if I convert the matrix and the transpose of a matrix, will be both are equal. Okay, this is called symmetric of a matrix, symmetric matrices. And skew symmetric is A transpose equal to minus A. Okay, if you take the transpose and take the minus sign of it, then A and minus A transpose will be equal. Okay, I am not giving you an example because I will discuss today all the GATE questions. So then you can easily find out this kind of questions and I will solve it. Okay, so this is another important point. Remember, the diagonal elements of a skew symmetric matrix is always 0. Okay, diagonal elements of a skew symmetric matrix is always 0, but not for symmetric matrix. If it is skew symmetric, then it is 0. Okay, invertible. Determinant A is not equal to 0. It is called invertible matrix. Okay, and orthogonal matrix A transpose is equal to A inverse, or we can say in other words, A into A transpose is equal to I. I means identity matrix. Okay, so these are the properties which are very important. Okay, to solve the problems in GATE questions. Okay, so remember these properties and practice. Practice of mathematics is very useful way to solve any kind of problem very easily. If you do not practice, then it will be difficult for you. Okay, so these are the important properties. Now I am going to discuss about the GATE questions related to whatever I have discussed, the properties, whatever I have discussed now. So now tell me, do you have any kind of questions, any queries, any kind of doubt? Then clear it. Then I will go to the question answer session. Anybody has any doubt, any query, then clear it now. In upper triangular, all the elements in the below, but he said that upper elements are 0. Will you please confirm it? Okay. Look at this. I am. Where is the upper triangular? Yes, this is. Look at this. Upper triangular means. Wait. Just. Use the eraser. Okay, upper triangular means suppose a matrix. I'm writing up a matrix like this. A matrix is divided into two parts. Okay, one part is below the diagonal element, another part is above the diagonal element. Okay, so if I draw the matrix or if I write down a matrix, it is divided into two parts. Okay, if it is a square matrix, remember it should be a square matrix that is 2 cross 2, 3 cross 3 like this. Then it can be divided into the two cases or two parts. Similarly, this matrix, look at this. This is the lower part of the diagonal element and this is the upper portion of the diagonal element. In case of upper triangular matrix, the upper portion of this diagonal element will be 0. That is, all the elements are 0. And in case of lower triangular matrix, the lower portion of this diagonal element will be all 0. Look at this is upper portion and this is lower portion. Similarly, this one. This is lower portion, this is upper portion. Okay, so lower triangular means the lower portion, all the elements of the lower portion is equal to 0. And upper triangular means all the upper portion of the diagonal elements will be 0. Okay, now did you get this point? Whatever I'm talking about, upper portion is 0, lower triangular means lower portion is 0. Don't bother about whatever the diagonal element is. It may be 0, it may be any other element, don't bother about it. Just divide the matrix with two parts, upper and lower. Can you get my point?
Excuse me, sir.
Yes.
Sorry, sir, but I just checked it on Google and it is written lower elements will be 0 for upper triangular matrix.
No. Lower elements will be 0. It is upper triangular matrix. Lower elements will be 0.
Yes, sir.
I don't think so. Please.
Sir, if you could check one more time.
Make me confused. Wait. Upper triangular, all the elements below the diagonals. Yes, you're right. Sorry. I am getting confused. Yes. Lower upper. Yes, you're right. Lower means this is upper will be 0, lower triangular. Okay, so this triangle, it forms a triangle, lower is 0 and just it is, I'm getting confused, just lower is upper and it is converted. Okay, so whatever it is, just divide this matrix into two parts.
Excuse me, sir.
Yes.
So I'm having a small doubt here.
Yes.
Since the name signifies as the upper triangular matrix, the right corner must be 0, sir, because the word itself says that it must be the upper matrix. Like how it can be told as the lower
I didn't
matrix and
get
the
you.
upper is 0.
Means
So the word says that it's upper triangular matrix, means it should be on top, isn't it, sir?
yes,
Upper triangular matrix, it must be in the
yes,
top.
yes, yes,
So
yes.
lower means it must be in the bottom. So the
It's the
name itself
bottom.
says that the upper matrix must be equal to 0, the upper triangular matrix. Then how it can be the lower triangular matrix having the upper
It is
element 0?
wait. It is just a notation. Okay, it is defined as this. It doesn't signifies any kind of solving of a matrix like this. If you just you are supposing this as a lower triangular, and you are solving the other problem, any other problem by considering this upper or lower triangular, the answer will be same. It is just a notation when it is discussed, that is whenever it is introduced into the mathematics, they just introduce as it is upper triangular and this is lower triangular. That is why we are just considering is it is an upper and considering it is a lower and nothing else. Okay, there is no other relation between the solving of a problem. It doesn't mean that the solution of the problem will be changed. Okay,
Okay.
it is just the definition and nothing else. Okay. There is no relation to the solution of any problem.
Okay, sir.
Okay. Further about the any kind of name. Okay. Just your main target is to solve any problem.
Okay, sir.
Okay. Okay. Any other question? Okay. Now I'm going to the solution of the problem. Okay. So these are some very important gate questions. Very small, very easy questions, but it is you have to do some tricks. First of all, to solve this question, I have to make sure about whether you remember. Suppose I already considered that you know the matrix multiplication. You all know the matrix multiplication. First, let me clear all of you that is matrix multiplication is known to all of you, because if you do not know the matrix multiplication, you will have some difficulty solving this problem. So everyone know what is matrix multiplication?
Yes, sir.
Okay. Then tell me one problem. Suppose I am giving a matrix A is equal to 1, 2, 3, 4. B is equal to can A cross B or A into B possible? Yes or no?
No, sir.
Why it is not possible?
Because M cross N and then that M must be equal, sir.
Exactly. Because matrix multiplication is first we multiply the rows with the columns. Okay, we multiply the rows with the columns. That is why there is 1, 2. This 1 is multiplied with this one, and this 2 is multiplied with this one. But this 5 will remain. So always remember the number of rows of A matrix will be equal to the number of columns. Sorry, the number of columns of A matrix should be equal to the number of rows of matrix B. So the number of column of this matrix is number of rows of this matrix is 3. So 2 is not equal to 3, so we can't multiply these two matrices. Okay, so remember this thing always. Secondly, another, suppose 1, 2, 3, 4 A and B is equal to suppose 1, 1, 2, 2, 5, 5, 1, 0, 1. A into B. What is the dimension of A into B?
This is also not possible, sir.
This is not possible. Okay. Now, This is, what is the dimension of A into B now?
So here it is 2 cross 2. There it is.
This is 2 cross 2.
Okay.
This is 2
The
cross
B
2.
the B matrix you're telling it to be 2 cross 3, sir.
2 cross 3. Yes.
Oh, okay. Then it is possible.
Yes. Now then, what is the, if I multiply this A into B, what is the dimension of it?
2 cross 3, sir.
2 cross 3. Exactly. 2 cross 3. It will be the dimension. Okay. So remember these two things. First thing, the number of rows of A matrix should be equal to the number of column. And I already told you that A cross B is not equal to B cross A. So we cannot consider B cross A. Always consider A should be in the left side and B should be in the right side. Okay. So the number of column of A should be equal to the number of rows of B. This is the first condition. Second condition, if it happens, the number of columns of A should be equal to the number of rows of B, it happens, then this is the dimension, final dimension after multiplication. Okay, so this example, look at this. This is 2 cross 2 matrix and this is 2 cross 3 matrix. So what is the dimension? The dimension of it will be 2 cross 3. Okay, 2 cross 3. That is the first one of this and the last one of this will be the dimension of A cross B. Okay, now tell me the answer of this one. Calculate it. And
Sir, is it that whole bracket, sir? Whole bracket of transpose. The last
yes,
one.
whole bracket of trans. Yes, the whole
Then the answer is 2 cross 2.
answer is 2 cross 2. Okay, anybody, please write down the answer in the chat box, everybody, and do not tell me the answer. Do not tell me, or just mute yourself. Just write down, everybody, write down the answer in the chat box. I just want to know that how many of you will have the idea of it. Everybody,
So in the
yes.
question, is anything written as X, sir? X transpose, something like that?
I am writing this. Okay. This is P. First it is P. Then it is X transpose. Then it is Y inverse. Then it is again P transpose and the whole bracket transpose. Okay.
Okay, sir.
Only 4 students have answered. 5. Okay, 1 minute more I can give you, but not more than that. Okay, your time is up. So let me do this. Some students, two students says 3 cross 3, and the rest of the other says A. Some didn't answer. Okay, so let me solve it. First of all, P, all the dimensions are given to you. The dimension of X is 4 cross 3. Okay, dimension of Y is 4 cross 3. Again, dimension of P is 2 cross 3. Okay, now whatever the other we need to find out here X transpose. Okay, so if X is 4 cross 3, then X transpose will be what? We are interchanging the rows and columns, that is rows with columns. Obviously it will be 3 cross 4. Okay, P transpose, there is no Y transpose, only P transpose is there. So P transpose. So what is the dimension of P transpose? It is 2 cross 3 previously. We are interchanging rows with the columns, it will be 3 cross 2. Okay, so whatever necessary, we have found everything. We need X transpose, we need P transpose, and all the other cases. Okay, now start with the lowest element, that is we are now finding P X transpose Y inverse P transpose and whole transpose. So it means P is 2 cross 3. Okay, X transpose, what is X transpose? X transpose means 3 cross 4. Y means 4 cross 3. Inverse P transpose is 3 cross 2, and it is whole transpose. Okay, sorry. Okay, now look at this one. First start with the brackets, the minimum brackets we are having. So X transpose, now just I discussed two matrices X transpose and Y are multiplied with each other. X transpose, the dimension is 3 cross 4 and Y dimension is 4 cross 3. So what will be the dimension of it? 3 cross 3, obviously 3 cross 3. So it will be P 2 cross 3. Okay, and I am just writing X transpose Y as Z. Okay, just consider X transpose Y equal to Z. It will be 3 cross 3. And inverse, and it is P transpose 3 cross 2. Okay, if Z has 3 cross 3, then what will be the Z inverse? What is the dimension of Z inverse? Always remember
The same,
inverse,
sir.
it is same. It will be same. Okay, inverse and the matrix itself will be the same. So it becomes 3 cross 3. Now you multiply like this. Okay, now if you multiply P into Z inverse, so P is 2 cross 3, Z inverse is 3 cross 3. And what will be the dimension? P into Z inverse, it will be 2 cross 3. Okay, so P Z inverse, I suppose this is as Z I already considered, it was A. Okay, P into Z inverse, I consider it A. And what will be the dimension of A? 2 cross 3. This one. 2 cross 3 into P transpose 3 cross 2. And now what is this? It is 2 and 2. So A, P transpose, what is the dimension? Let us suppose P and T, it will be capital B. It is 2 cross 2. So the dimension of the final, it will be 2 cross 2. That is answer is A. Okay, anybody has any doubt? Those who have answered 3 cross 3. Okay, did you get this point? Get this answer?
Understood, sir.
Okay. Next question. This is very easy. The inverse of the matrix 2 cross 2. Okay, I think all of you know what is the inverse of a matrix. That is how to find out the inverse of a matrix. If you anyone has any query about inverse, then I will explain how to find out inverse. Okay, so if you know everyone what is inverse, then please solve this question. The inverse of 2 cross 2 matrix, this is which one? Okay, one answer I got C, two answer C. C. A. Okay. 3C, 2A. 3C, 3A. Okay. Should I stop the poll now? I think almost all of you. No, some students are remaining. Okay, some says C, some says A. Almost 50-50 answers I am getting. So I think many of you do not have idea, or if you have the idea, you have forgotten about finding of inverse of a matrix. Inverse of a matrix, first remember this one. Inverse is equal to inverse of A, suppose, or we can see A inverse, we can say it is adjoint A, adjoint of A divided by determinant of A. So determinant of A is very easy to find because because determinant of A is, it is 1 2 3, 5 7. The determinant of 1 2 5 7 is equal to, it is very simple, just cross multiplication. Okay, 1 into 7 minus 5 into 2. Okay, so 7 minus 10. Okay, 7 minus 10, it will be minus 3. Okay, so it is determinant of it is minus 3. So now we need to find out the adjoint one. So how to find out the adjoint one? How to find out the adjoint one? The adjoint one is 1 2 5 7. This is the matrix. Okay, to find out the adjoint one, first to find out the cofactor matrix. Cofactor matrix is nothing but first row and first column should be deleted. Okay, that is 7. Write down the 7 here. Okay, second, first row and second column should be deleted. what is remained? 5. Okay, write down here 5. Third, second row first column will be deleted. What is remaining? 2. Write down here 2. Okay, next, second row second column will be deleted, and what is left? 1. Right here 1. Okay, after finding, this is called cofactor matrix. Okay, cofactor means just deleting first row. Each and every element has its corresponding cofactor. That is, if I find out the cofactor of 7 means this row and this column will be deleted, and the remaining element, that is this 1, will be the cofactor of 7. This is called cofactor. So first you need to find out the matrix, and after finding the cofactor, find out the transpose of it. That is 7251. And then simply write down the options. That is, write down the sign like this. First it is minus, plus, minus, plus. That is your matrix. It becomes, this is the adjoint. 7 minus 7, 2, 5, minus 1. This is called adjoint of a matrix. Okay, so if it is adjoint of a matrix, the formula is adjoint A by determinant A. Okay, so adjoint A by determinant A, so determinant is minus 3. Determinant A is minus 3. This is 1 and 1.
Sir, adjoint A minus
Sorry.
2 minus 5 now, sir.
Yes. I just plus minus. Just okay, so this is adjoint A. And if I divided it by determinant A, so determinant A means minus 3. So it is equal to 1 by 3 minus 7, 2, 5, minus 1. The answer is A. A is the answer. Okay, so A is the answer. So if you don't know how to find out the adjoint A, so adjoint is called the cofactor matrix and the transpose of it. Okay, and the cofactor matrix is, to find out, if you do not know the cofactor matrix, I will discuss it later. Okay, first let me complete all these questions and then
Sir,
discuss everything. Yes.
like why, like we should assign the signs before taking the transpose, right?
I'm not getting it.
Yeah, basically it's like cofactor is -1 raised to the power the
Yes. Actually, what we are doing,
row
I
to the
am
column, right? So first, like,
exactly.
yeah, so it should be before, right? When you're getting this point, 7521, and then you written the transpose. So basically, the sign should come at this point, and then after taking the transpose, it should be option C, right?
No. It's option A. Transpose. First, we are getting the transpose.
Okay.
And then we will find out this one. Okay, first you have to get the transpose. The sign will be assigned after that. Sign
Okay.
will be assigned after that, and sign is there is nothing but it is the summation of rows and columns whole to the power that -1 whole to the
Yeah, correct.
Okay, actually we are doing this one and nothing.
Okay.
So cofactor matrix, it is a very small matrix, so that is why it is very easy to find out the cofactor matrix. But it is a large matrix, then large matrix is, I don't think so in GATE exam that kind of questions will be appeared in the exam. Okay, so this kind of question, it is very easy because this is a GATE question. Okay, I will discuss about the cofactors and cofactor matrix later, but first let me discuss about all these GATE questions.
Yeah.
Our next question is this one. The product of the matrix is this, that is of this matrix is, then what is the correct answer? What is the product of this matrix? P. Okay, so I'm stopping the poll now. Look at this. It is P, Q, inverse P. Okay, so it is another property I just discussed. P, Q whole inverse, that is AB whole inverse. Okay, AB whole inverse, if it is, it means it is B inverse A inverse. Okay, so if it is whole inverse, just like a transpose, AB whole transpose, B transpose, A transpose, so just like that, AB whole inverse is B inverse, A inverse. So PQ whole inverse, we can write it Q inverse, P inverse, and P. And we all know that is P inverse P is equal to what? Is nothing but the identity matrix I. So it is equal to Q inverse P inverse P, and P inverse P is equals to I. So it is Q inverse I, and Q inverse I equal to Q inverse itself. So answer is B. Okay, so just you need to remember a very small formula, that is a very easy formula. The whole inverse of P and Q. Q inverse P inverse and P into P inverse. The next formula is P into P inverse is equal to I. I means the identity matrix. And any matrix which is multiplied with identity matrix is give you the same matrix. So answer will be Q inverse. Okay, any doubt? Okay, our next problem is this one. The inverse of this matrix is what? Okay, I will stop the poll now. Now I will show you the basic method, that is the original method to find out the inverse, that is how to find out the adjoint. Okay, this is like this. Suppose a 3 cross 3 matrix. First I told you that I will find the cofactor matrix. Suppose I am considering a matrix like this: 1 2 3 4 5 6 7 8 9. The cofactor, always remember, each and every element of a matrix has the cofactor. If I consider what is the cofactor of 1, what is the cofactor of 1? Just you consider the row and column which intersects the element 1. That is, what is the cofactor of 1? If the intersection row and column will be deleted or will be nullified. So 1, what is the intersection? The first row and first column intersection is 1. So I delete the first row and first column, and the rest of the elements is called the cofactor. It is 5, 6, 8, 9. This is the cofactor of 1. So each and every element has the cofactor. Similarly, 2. What is the cofactor of 2? We need to find out. Just let me. Now, what is the cofactor of 2? So the intersection, 2 intersects. Okay, what is the row and column which is intersected with these 2? First row and the second column is the intersection of 2. Okay, so the first row and the second column will be deleted, and the rest of the element, that is this one and this one, we'll take it 4, 7, 6, 9. Okay, will be the cofactor of 2. Okay, so if any gate question, there may be in the gate questions, what is the cofactor of 1 or what is the cofactor of this? Okay, the element, the matrix will be a very bigger matrix, and in that case the cofactor of this matrix and cofactor of that matrix will be more difficult. Okay, so then we need to find out what is the cofactor. This is that row and that column should be deleted, which is intersected with, which intersects that element. Similarly, cofactor of 3, first row 3 is situated in the first row and the last column, that is third column. So first row and third column will be deleted, and this is the cofactor of 3. Okay, now how to assign the sign, that is whether the sign is positive or negative. How to assign the sign? To assign the sign, we need to nothing. Look at this 1. 1 means it's situated in the first row and the first column. So first row and first column, we just add it. And what is the sign of this cofactor? The sign is -1 whole to the power 1 plus 1, because first row and first column we have considered. Similarly, how to assign the sign of the cofactor of 2? So 2 exists in first row and second column, that is 1 plus 2. So the sign of this cofactor will be -1 whole to the power 1 plus 2. Okay. Similarly, what is the cofactor of 3? So 3 cofactor, it is 3 and 3. So 1 plus 3. First row and third column, so 1 plus 3. So sign is -1 whole to the power 1 plus 3. Okay. So it is just like this. We have to assign the sign like this. Okay, now if I go to this one, okay, so now cofactor, since the cofactor here is only the element, because the matrix is itself 2 cross 2. So what is the cofactor of this one? The cofactor of this one is 3 minus 2y. And what is the sign? Sign is 1 plus 1. Okay, so -1 whole to the power minus 1 whole to the power 1 plus 1. Okay, minus 1 whole to the power 1 plus 1 means minus 1 whole square, and it is plus sign. Now what is the cofactor of this one? The cofactor of this one is minus I. So minus I. And what is the symbol? It is 1 plus 2. So minus 1 whole to the power 1 plus 2. It is minus 1 whole to the power 3, which is minus. Minus of minus I, it becomes plus. Next, this one. Cofactor is I. Okay. So I. So I means what is the symbol? It is 2 plus 1. 2 plus 1 is 3. So it is minus. Minus 1 whole to the power 3 means minus. And the last one, it is this one. So 3 plus 2i. And obviously it is plus because 2 plus 2, it is plus. Okay, transpose. So this is the original method to find out the inverse of a matrix. Okay, so it is first we find out 3 minus 2i, it is I, it is minus I, and it is 3 plus 2i. Transpose, it becomes 3 minus 2i minus I, and it is I, 3 plus 2i. Okay, and what is the determinant of this matrix? Determinant is nothing but 3 minus 2i into 3 plus 2i minus I square equal to minus 1. First of all, this is minus sign is already there, so it becomes plus sign. So I square equal to minus 1. Okay, and it is 3 plus 2i and 3 minus, it is 3 square, and it is minus 2i square. A square minus b square formula, a plus b into e minus b. 9 minus I square equal to minus 1, it is always plus, so 4, 13. So 1 by 13, sorry,
1 by 14.
1 by 14, sorry, 14.
I square.
Yes, 1 by 14. So 1 by 14 into this one. Okay. Next, tell me the answer of this. This is a tricky question, but very easy. 7 by 30, there is no option like 7 by 30. 7 by 20 is there. Abhijit.
Yeah, sir, but like that.
This is actually a great question. Okay, I just copied and pasted here.
No, sir. Yeah. Okay.
Less possibility that the answer is wrong. You are taking long time. This much time you won't get. Okay, 1 minute. Okay, I'm stopping the poll here. So, a very simple property, what just I have discussed previously, and if you apply that property, this will be solved very easily. A inverse is equal to I. This is the property you have to remember here. Just put A. A means 2 minus 0.1. Okay, I'm converting this minus 0.1 as minus 1 by 10. 0, 3. A inverse. A inverse is, okay, now A inverse is already given to you. Half A 0 B. Okay, is equal to I. I means 1 0 0 1. Okay, so A inverse equal to A plus B. So if it is this one, so how can you do this? Very easy, very simple. You just need to find out these two values. Just simply multiply this. 2 into half is equals to 1, 1, and it is 0. So it is 1. It is 2A minus B by 10. Okay, 2A minus B by 10. Yes, and it is 0, 0. Yes, it is 0. It is 0, 3B. Okay. So this is equal to 1 0 0 1. So 2A, so two equations we are getting. 2A minus B by 10 is equal to 0. That is this one. This is equal to this one, and this is equal to this one. Okay, and 3B is equal to 1. So B is equal to 1 by 3. Okay, and what is A? If B is equal to 1 by 3, then what is A? 2A is equal to B by 10. So B equal to 1 by 3. So 1 by 3 means 1 by 30. So A is equal to 60. 1 by 60. Okay, so B is equal to 1 by 30 and it is 1 by 60. Sorry, 1 by 3, 1 by 60. Okay, and just you solve it and you can easily get the answer. So 3 and 60, just simply multiplication, that is 3, 1, 20, 60, 21 by 60, 7 by 20. A is the right answer.
Sir, excuse me, sir.
Yes.
Sir, would you please check previous question answer, sir, solution once again?
Previous question. Which one is previous? This one.
Yeah, sir. Sir, determinant will be 1 by 12, I guess, sir.
By 12. Maybe 12. Determinant is.
Minus
Okay, okay. I'm solving it.
I square. Yes.
I square equal to minus 1.
Minus 1.
I square always minus 1. The matrix is 3. Oh, sorry. Matrix is this into this. So it is 3 plus 2i. Okay. And it is 3 minus 2i. Okay. Minus of this is I into minus I into I. This is minus. So it will be I square plus I square. Am I right?
Yes, sir.
It's plus I square. So it is again minus 1. Now 3 plus 2i, 3 minus 2i. A plus B into A minus B formula.
So,
A plus B into A minus B, A square minus B square. 3 square minus 2i square. Okay.
yes, sir.
Plus, so I square minus 1, it will be minus 1.
Yes.
3 square means 9. Okay. Now this is 2 square equal to 4. Now I square equal to minus 1. 4 into minus 1, it means plus.
Plus.
Minus 1. Okay. 9 plus 3. 12. Yes, it is 12. 12, 12, yes. Okay. It's simple calculation. You are just while calculating, just concentrate. Otherwise, these kinds of problem, there is very high possibility of mistake. Okay, so this problem, now look at this problem. This problem, maybe you can just simply find out A inverse here, but it will take more time. So if you apply this formula, A into A inverse equal to I, maybe it will take less time. Just simply find out two equations, and 3b equal to 1, it is very easy to find. Okay, so this is the basic problems of mathematics and the basic guest questions. Now the second part, which is matrix 2, that is the advanced part of the matrix, which is related to the elementary row and column operations, rank of a matrix, and eigenvalue and eigenvector of a matrix. Okay, and solving of system of linear equations. Okay, there are many tricky questions out there from solving of system of linear equations. So you can now I will explain it. I don't think so the whole chapter will be completed today, but rank, elementary row operations, and a part of eigenvalue and eigenvector, it can be completed. Okay, I'm taking just a 3 to 4 minutes break. I will join you again. Aishwarya ma'am, are you present there? I have a problem. The problem is the screen share. In case of screen sharing, I have to share whole screen. I can't share again. That problem occurs. That is this application. Second button means leave meeting. Yeah. Yes, now it is visible. Okay. Okay, I'm coming back to after just 3 or 4 minutes.
Hello. Hello, ma'am. Good evening, ma'am. Yes, sir, ma'am. Ma'am. Yeah, ma'am. Ma'am, I have one problem that I sent on WhatsApp, ma'am, please. Ma'am, Mohr circles formula is different taught in my college, and in video there is another. Yeah, ma'am. Which one would you follow? Yeah, ma'am. Yeah. Okay. Yes, ma'am. Yes, yeah, ma'am. Yes, ma'am. Ma'am, in under root, ma'am. The radius is in under root, ma'am. Yes, ma'am. Okay, ma'am. Okay, ma'am. I confused, just confused. Sorry, ma'am. I confused both of formulas. Okay. I got it. Thank you, ma'am. And sorry for. Okay, ma'am. Thank you.
Okay, hello. Am I audible to everyone?
Yes, sir.
Okay. Now, can you see the screen?
Yes, sir.
Okay. Okay, so now the matrix 1, that is the basic operations on matrix, is has been completed. Now this is the advanced operations, and which is called the elementary row and column operations and rank finding. So elementary row operations and column operations, actually these operations, if we operate any kind of operations on matrix, maybe it is elementary row or elementary column, the final matrix and the previous matrix doesn't change. That is, they are equivalent to each other. Okay, so same case, we are using this technique to find out the solution of system of linear equations, and which is the most effective part of this elementary application of these elementary row and column operations. Okay, so what is it? First, I just need to discuss it slightly. Suppose a matrix is given as 2, 1, 2, 2, 3, 3, 3. Okay, matrix is given as this. Now, what is row operation? Row operation means we can just this second row and first row can be added or can be multiplied. Okay, that is, if I write here, suppose this is R1, this is R2, this is R3, means row 1, row 2, row 3. We can add row 1 and row 2. Okay, we can add row 1 and row 2. If I write here R2 plus R1, okay, so what does it mean? It means that we are changing the row R2. We are changing the row R2 with respect to the row R1 with the operation plus. What does it mean? It means nothing. We are just adding this row 1 and row 2. Okay, but the after addition, the changes will be occurred in row 2, not in row 1. Remember this always. Okay, so in the first position, whatever we are writing in the first position, R2, we are writing first position in R2. So R2 means row 2 will be changed and row 1 will not be changed. So what is the final result? It is A11, A22, A33, A11 plus A21, A22 plus A22, sorry, A11, A12, 13, 122 plus 12, and this is A13 plus A23. Okay, so second row will be changed. We are just adding the two rows, first row and second row, but the changing row will be row 2, and row 3 will be similar as it is. After this operation, this matrix and this matrix will be equivalent to each other. Okay, there is no change. So this technique we will apply to find out the system of solution, the solution of the system of linear equations. Okay, so solution of the system, that is also very important in GATE exam, but I will discuss it later. First, I will discuss what is the how to find out the rank. Now, rank finding, it is suppose this matrix. First of all, let me know that whether do you know how to find rank by using this elementary row and column operation. You can write it in the chat box if you know. Okay, everyone, if anyone has any kind of problem, no. Okay, Irfan doesn't know this. Any other? Okay, if you know this, you don't have to write anything. If you do not know, then write in the chat box that you don't know. Then I will explain. Irfan, you don't know this. Okay, I will explain it. Okay. Okay, so maximum of you says you know that, then find the rank of this one. Then I will explain. Who do not know, I will explain it how to find the rank. Maximum of you know how to find that rank, so tell me the answer. C. Okay. Only 3 students have answered.
Sir, can you give the 1 minute, please? Am I audible? Hello? Hello? Am I audible, sir? Yes, I'm just trying to tell. I just need some time. That's all, ma'am. But I guess is sir there, ma'am?
Okay. Can I stop it now? Okay. Now I'm stopping the poll. You took much times. So look at this. Those who do not know how to find out the rank of a matrix, I have a very simple trick. The trick is, first, your first trick will be make this element 1 and this element 1. If it is already 1 and 1, don't need to find out anything. Okay, your next task will be second and third element of this first column will be 0 and 0. Your always first target will be second and third element of this first, which can make this second and third element as 0. Okay, so let's try this. One, 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 1 minus 1, 0, 1, 1, 1. So make this one and this one 0, your first target. So how can you do this? Just I have explained this one, this matrix. That is, if I want to change something, that should be written in the first case. So you don't write it because this is a MCQ type of questions. So whatever you write, nobody will watch. Just always remember your operations will be perfect and nothing else. So our first operation is to change this one, this element, and this is R2, this is R1, this is R3. So I want to change this R2, the first element of this R2 as 0. So what should I do? With respect to this R1, if I just subtract this one and this one, then it will be 0. And if I subtract this one and this one, it will be again 0. Okay, so our operation is R2 minus R1 and R3 minus R1. Okay, so R1 is fixed because R1 in the second position. So R1 is always fixed 1 1 1. So R2 minus R1, it means just we need to simply we are subtracting R2 and R1. So 1 minus 1, it is 0. Minus 1, 1. So minus 1, it is minus 2. 0 minus 1, minus 1. 1 minus 1. 1 minus 1, 0. 1 minus 1, 0. Okay. Now you have to check that whether the matrix transformed into an upper triangular matrix or not. Okay, look at this. This becomes an upper triangular matrix because our lower elements are all 0. If it happens, you stop operating anything. Just your operation is stopped now because you already obtained this upper triangular matrix. Okay. So in this case, now at this position, you just count the number of rows, the non-zero rows. So first row, this is non-zero row. Second row, this is also non-zero row. Third row is a 0 row. Okay, so number of non-zero row is 1 and 1. So 2 will be the rank of the matrix. So C is the right answer, 2. Okay, so your operations will be first, always your target will be make this element, that is this one and this one as 0 element. Okay, and then this one as 0 element. That is just to form an upper triangular matrix. So if just one operation, one or two operations, it's done, then it is okay. So after getting this upper triangular matrix, that is this and this, your target is these 3 elements will be 0. Whatever the operations you will do, so that these 3 elements will be 0. If you can get number of 0 rows as 1, then it is rank is 2. The number of non-zero row will be the number of rank of this matrix. Okay, second, another, find the rank of this one. This is the one of the most important questions in GATE, that is finding of rank. Many times in GATE questions, the rank finding questions are every year you can face this kind of questions, rank of a matrix. Okay, A, that is 1. Next,
Hello, sir.
Yes.
Sir, your presenting screen is black. Now it comes.
Now you can see.
Yeah, now I can see.
Okay. Okay, almost all of you says A is the right answer. Okay. Actually, the question is very easy. Okay, you don't have to look. Just the first target I told you, that is to make this element and this element as zero element. Okay, and everything will be done. Look at this. It is 3 minus 4 and 18. It is 12, 8 minus 36. Everything is written very properly here. If I want to make this element as 0 and this element as 0 with respect to this one, then what is the operation we should do? It is, look at this, it is minus 6. So R2 plus 3 into 2, that is 6, there is 2R1. This is the first operation. And the second operation will be R3 minus 4 into R1. Now look at this. If I operate this one, so first row will be minus 9. Second row will be, it is obviously 0. It is 2. It is also 0. 18. And it is 2 into minus 9. 18 plus 2 into minus 9 is 0. It is obviously 0. 8 minus 4 into 2, it is 0. Minus 36 minus of minus 9 into 4, it is plus 36, again 0. So already this matrix is question is very easy. Everything is written properly here. So that is why just using this operation you can get this simple matrix 0, 0. That is 2 rows are 0 here. So only one non-zero row is the first row. So the rank of the matrix is 1.
Excuse me, sir.
Yes.
So I have a small.
Yes.
So by using the row and column operations, we can do it. But can we use the determinant method also, sir?
Yes, you can do it also, but
because the determinant method will be saving a lot of time for us. So only I told, sir.
Yes, you can do this. Depends on the matrix. Look at this. This matrix, it is, you can just easily see this matrix. If you multiply this 3 into 2, everything is matched with this one. If you multiply this into this, everything. Actually, this matrix doesn't need any operation. Okay, if you have the practice, just seeing this matrix, you can easily say yes, 1 will be the rank.
Okay, sir.
No operation will actually you need to apply here. Because look at this, just everything is multiplication of 3 and 2. Minus 6, minus 4 and 18. And look at this, signs are also different. This is plus, this is minus. This is plus, this is minus, this is minus, this is plus. So whenever you find this kind of matrix, don't operate anything, just blindly you can say 1 is the rank. It depends on the practice and nothing else.
Okay, sir.
Okay. Okay, next one. This is a tricky question. Consistent and inconsistent rank of a matrix. I see that you all ever about rank of a matrix very firmly. So that is why I am going to the system of linear equations. Okay, to find out the system of linear equations, first we need to explain what is an augmented matrix. Sorry. Augmented matrix. First of all, any system of linear equations can be expressed as Ax is equal to B. Okay, I'm just explaining it. Suppose 2x plus 3y is equal to 1. 3x equals to 2. Not 2, it is suppose 1 by 2, like this. Okay, so how can you represent this system of linear equations into this matrix form? We can simply use the matrix as 2, 3, 3, 1. That is this one, 2, 3, 3, 1. xy as a column vector. This is a vector actually. xy is called a column vector. And 1/2, sorry, 1/2. Okay, this is another vector. So first matrix, this matrix is A. This vector xy is x, capital X. This is just the representation. Okay, and this vector is called small b. So this can be represented as Ax is equal to B. Okay, so now rank of A, you can easily find out the rank of A. So after you to find out whether a system of equation, that is this system of equation may have some solution, may not have some solution. Okay, it depends on some properties, whether a system of linear equation has some solution or not. The system of linear equation may have some solution, may not have some solution. So how to find out whether the system of equation has some solution or not? There are two kind of matrices. One is A matrix, which is equal to 2, 3, 3, 1. Another matrix is called augmented matrix, which is AB matrix. That is, first write down the A matrix 2, 3, 3, 1, and then write down B matrix, that is half. This total matrix is called augmented matrix, and this is a simple A matrix. The system of linear equation has only the solution, have the solution if the rank of this augmented matrix and rank of this simple matrix will be equal. If it is unequal, then the system is called inconsistent system. Okay, so the property is the system is consistent. Consistent means it has T. The system is consistent. Consistent means it has some solution. Okay, so if consistent system, then rank of A will be equal to the rank of the augmented matrix, that is AB. Okay, remember this one. And inconsistent, if rank of A is not equal to the rank of AB. Okay, now can anybody say me that is rank of this system, sorry, the solution of this system exist or not? Is it consistent system or inconsistent system? 2x plus 3y equal to 1, 3x plus y equal to half. Is this system consistent or inconsistent? Please write it in the chat box. Consistent?
Yes, sir.
Yes. So first find out the rank of A and find out the rank of this AB. Okay. So the trick is, don't find out the rank of A, because directly you can find out the rank of AB. And after finding the rank of AB, you can easily find out the rank of A and rank of AB easily. Okay. So now going to the question. My question is this one. Now you know why the system is inconsistent, or the system is, when the system is inconsistent and system is consistent. Now tell me the answer of this question. A is 3 cross 4 matrix, real matrix, and AX is equal to B is inconsistent system. It is given to you that the system is inconsistent. Then what is the highest possible rank of A?
Sir,
Yes.
I'm not able to solve, sir.
Okay. Wait, I will solve it. Okay, anyone would like to answer? I am getting mixed answers. Someone says A, someone says 3, someone says B. Okay. I'm giving you 1 more minute to solve it. And I'm giving a hint. Hint is number of non-zero rows will give you the rank of a matrix. Okay, so apply the rule. Number of first, just consider an augmented matrix. Just write down any matrix A and B. Ax equal to B, consider any system of linear equation. Okay, consider an augmented matrix and always remember number of non-zero rows will give you the rank of a matrix. So what is the situation? There is a system is inconsistent. First of all, you need to know this. What is the situation when system becomes inconsistent? So system becomes inconsistent. Okay, I am solving it. Suppose Ax equal to B. Okay, so the system becomes inconsistent system if I told you that rank are not matched to each other. The total matrix is augmented matrix. Okay, and this matrix is A matrix. Now suppose in any situation this rank will not match, that is rank will not be matched. If I consider this happens, the rank of A will be 2. What is the highest rank of A? Obviously the highest rank of A will be 3. And what is the highest rank of AB? The highest rank of AB, obviously it is 3, because there are 3 rows. For A and for B, the rows are 3. So highest rank of both A and AB will be 3 itself. Now what is the condition when the rank of AB and rank of A will not match? And what is the highest rank when it will not match? Obviously the rank of A will be 2. The highest rank will be 2. Then we can say the system is inconsistent. That is, the last row of this matrix will be 0, 0, 0. But this doesn't become 0. Then we can say that rank of AB is equal to 3 and rank of A is equal to 2.
Excuse me, sir.
Yes.
So how do you say that the last row, all the elements are becoming 0?
No. I am not saying it. I am just considering, look at this. This particular question doesn't have any particular matrix. It only gives you the A cross 4 or B cross 3, anything. A simple matrix A and B is given to you. And it says, it asks you, what is the condition? That is, condition mean what is the highest rank of A, which gives you the system is inconsistent. So I told you that inconsistent system means rank of A and rank of AB will not equal.
Yes.
Isn't it? So rank of A, so what is the condition when rank of A will not be equal to the rank of AB? What is the condition? Look at this matrix. Cross means it has some element, non-zero element, and 0 means 0 element. Look at this situation. This is A matrix and the total matrix is AB matrix. So what is the rank of AB in this condition? Tell me.
The highest is 3, sir.
Highest is 3. That is AB rank. Okay. Augmented matrix rank is 3. And what is the rank of A now?
Now A is 2, sir.
Exactly. So in this case, rank of AB and rank of A is not equal.
Not equal.
We can say the system is inconsistent. Isn't it?
Like, sir, what if 2 rows are becoming 0?
2 rows. Yeah. Look at this. This is highest possible rank is getting. This is the highest possible. Okay. If 2 rows is becoming 0, then it is obviously an inconsistent system. This is obviously inconsistent. But what is the highest condition? Highest possible rank of A. Highest possible rank of A is 2. It is only if the third row becomes 0, then we can say that rank of AB is 3, rank of A is 2. That is, system rank doesn't match. This is the highest possible condition. Obviously,
Okay,
this row may be 0. Yes, it is okay. It is also inconsistent. But what is the highest? Obviously, the highest rank will be 2.
Yes, sir. Okay.
Okay?
Sir,
Yes, sir. Yes, sir. Got it.
Yes.
sir, is it possible that rank of AB becomes 2 and rank of A becomes 3? Then the system will also inconsistent.
How it is possible?
Sir, I am just asking.
If not just it is very basic thing. It is actually not possible because look at this. If I say this is 0, if I say this is 0, then rank will be equal. This is 2 and this is 2. So system again becomes consistent system. Okay. Whenever you are trying to find out a rank, obviously this kinds of we are trying to find out the upper triangular. That is, you are trying to find out the 0 in the left side. So first right side will be 0 and left side doesn't 0. It is rank of A. Always remember, rank of A for inconsistent system, it should be the less than the rank of AB. Okay, then it is called it is inconsistent. And what is the highest system? Obviously it is 2 will be, means rank is 2 for A and rank is 3 for AB. It is any last condition, last element, it is non-zero element, it means this rank is 3. The AB rank will be 3. So only this is the only possible. If you think about it, if you just try it yourself in the home, just write it.
Sir,
It is not
can you
possible.
explain once again rank of AB equal to 3? How is it?
Okay, wait. Suppose I am okay. So if you try to find out any row and column operation, what should you do first? You will first make it 0 and 0. Okay. And suppose these are the elements will be like this. These elements will not 0. Some other elements will be there. Like this. What is your second duty? To find this element as 0. Okay, find this element as 0. So after taking this element as 0, suppose your final you can get this upper triangular matrix. Okay, no more other operation is left. Okay, so when after some elementary row operations you can get this matrix. No other operation is left. So you can see that what is the rank of this augmented matrix, this total matrix rank. How many non-zero row is there? 1, 2, 3. 3 non-zero row is there. Isn't it? The total matrix, AB matrix, that is this total one.
Oh, okay, sir.
It is 3.
Got it.
And what is the rank of A? 1, 2, 3.
Three.
It is also 3. Rank of A is 3, rank of AB is 3. Then the system of linear equation is consistent, that is, it has some solution. Okay, but somehow, suppose this element becomes 0. This element becomes 0. Then what is the rank of this total matrix?
It will be 3.
3. But what is the rank of this A?
2. It will be
Inconsistent system. Then for inconsistent system, what is the highest possible rank of A? 2 is the highest possible rank because there is no other option. The first inconsistent system occurs if the last row of A will be 0, 0, 0. And if I consider the whole matrix, these 3 elements will be 0 and only 15, that is this element, non-zero element. Then it is 3 and it is 2. This is the highest possible possibility of an inconsistent system. Now can you get it?
yes, sir.
Okay, so already the time is over. So anybody has any kind of doubt or question?
No, sir.
Okay, then I will leave the session for today. Aishwarya ma'am, are you there? Hello. Yes. So I'm ending the session. Okay, welcome. Yes, Wednesday. Yeah. Okay. Thank you. Thank you for attending my class.